Okay, in this lesson, what we're doing is we're looking at average rates of change and how to calculate those. So I'll abbreviate average rate of change as AROC, so AROC. And really what the average rate of change is it's the slope of a secant line along a curve. So if I were to take some random function f, so I have f here in yellow, and I wanted to find the average rate of change between point A and point B, what I could do is I could connect those two dots, and the slope of that line represents the average rate of change. So what this is, the slope, m, is simply the change in y divided by the change in x. You could represent that as the second y value minus the first y value divided by the second x value minus the first x value, or in terms of functions, this is simply f of b minus f of a divided by b minus a. So to look at an example of AROC, you might see something like this. Find the average rate of change of f of x equals 2x squared minus x plus 1 on the closed interval 0 to 4. So if you're given something like this, all you need to do is find the slope of the secant line. So we're going to say that the average rate of change is equal to the change in y over the change in x, which in this case I know is f of 4 minus f of 0 divided by 4 minus 0. So I just need to find out what f of 4 is. So I simply plug that into my function. So this is 2 times 4 squared minus 4 plus 1 divided by 4 minus 0. I'm sorry, I also need to subtract f of 0. So f of 4 is 2 times 4 squared minus 4 plus 1. So I'm going to have 2 times 0 squared minus 0 plus 1 as my f of 0. Calculating this, 4 squared is 16, and 16 times 2 is 32, minus 4 plus 1, minus the quantity 0 squared is 0, 0 times 2 is 0, minus 0 is still 0, plus 1 is 1. All of that's divided by 4 minus 0, which is 4. 32 minus 4 is 28. 28 plus 1 is 29. And 29 minus 1 is 28. So I end up with 28 over 4, which we all know is 7. So what this tells me is that the average slope, or the average rate of change between 0 and 4, my x values on this particular function, has a slope of 7.